Now let's move to the Norton equivalent circuit. Norton equivalent circuit consists of an independent current source with one Thevenin resistance. So that's the basic concept. And they two elements, they are connected in parallel. So let's take a look at the one example on here. Okay, so this example circuit was given, and now find out the Norton equivalent circuit. So first step, all step is same. So now first we need to calculate about VT, and then open circuit voltage, and then we need to find out the short circuit, and we need to find out the resistance, the Thevenin or Norton equivalent. So now we can put the Norton equivalent resistance. So now VT, so we can apply node voltage analysis, VOC, which means that here this node and those are all the parallel now. So VOC, we say that this one is VOC, which means that we can put node A, node B, so VA node, A node, and B node. So we say that VB, those are all the same, those are all equal VOC because of the parallel, and those are one dependent voltage Vx over 4, that's dependent voltage. And now node voltage analysis at this point, so B point. So we can set up the current flow. This is reference, so this is going down, and we say that this one is I2, and this one's because of the source, so we can say that goes up, and we can say that I1. Okay, so I1's and this directions I2, and the other one is the current. We say that this one is this directions I3. Again, this one's I still 2 and pass through it. Right? So now then A node, we say KCL equation at node A. Current coming in, current coming out. Current I, so we can express it from one end of the resistance and the other end. So this one end of the resistor, that is 15 volt, and the other end is 0 volt. They connected to reference. So 15 volt minus VA, which means that VOC. Okay, and the resistance 20. I2 from on top of the end and the ground. So we say that VOC is still same voltage, I already told you. So VOC minus 0, and the voltage, those are all series connections. So 15 plus 5, which means 20. And I3 current, how much is current? Vx plus 4. So those equations we can obtain. We can multiply 20 in the both sides, so then we can get 15 minus VOC and VOC plus 5 Vx. So we obtained one equations. In the seconds, so in here there is voltage division occur, voltage divider. So current coming in and voltage across here, VOC voltage will divide because of the current resistance. So 15 to 5 ratios, which means that 3-1. So voltage division will occur. So here is the Vx, which means that here to here 3 times bigger, so 3Vx because of the voltage divisions. Okay, So 1/4 in this 1/4 voltage will be found in the 5 ohm resistors, and 3/4 voltage will be found in the 15 resistor ohm because of the voltage divisions. So which means that from here to here, that is VOC. So which means that VOC is Vx plus 3Vx. So which means that 4Vx. Okay. So now here second equations we can obtain. So now we can plug in into these equations. Alright, these equations. So Vx plug in here. So which means that VOC 1 over VOC, and 15 minus VOC equal VOC plus 5 times 4 VOC. Okay, so now those equations we can obtain it. And the next we can multiply 4, so and this one is moved to here, and multiply 4, then 60, and multiply 4, so 4 and 4, so total 8 VOC plus 5 VOC, and total 13. So how much is it? So let's do the calculations. 60 over, so now here 60 divided by 13, so 4.6. This value is 4.61 volt. So we find out voltage 4.61 volt. That's the open circuit voltage. And next is short circuit voltage, short circuit current. So short circuit current, so intentionally we can connect it to terminal with the short circuit. There is no resistance, so that current flow in these directions. There is no direction, so no current into these two resistors. Because of resistor, current will not go in, only they will flow into the short circuit. So which means that I2 is 0, which means that another one important thing is that current I2 is 0, which means that Vx also 0, because no current, so Vx is 0. One important thing is that Vx is 0, then that one is dependent on this voltage across the R3. So Vx is 0, which means that that one also 0, because this one is dependent value, dependent of Vx. So this one is 0 and that one is 0. So now remaining circuit is that. So we can obtain here's remaining circuit. You can redraw it, and then there is no kinds of short circuits and no current on here, so short circuits and short circuit connected. So here ISC, and now this one is 20 ohm and that one is 15 volt. So current flow in these directions. So ISC equal V over R. So V is 15s and ohms 20 ohm, so 0.7 amps. That's short circuit amp. And now two value was found, so now we can calculate the Thevenin resistance voltage resistance. So V over I 4.61 over 1.7 0.75. So let's do calculations. And how much is it? 4061 divided by 0.75, so 6.1 ohms. So now we got 6.1 ohm. So now all the value was given, so now we can draw Norton equivalent circuits. Norton equivalent circuits, current, and we know the resistance, and they are connected into the open to terminal. So current Norton, that is 0.75 amp, and resistance in Norton, that is 6.1 ohms. So we can get this result. It's a little complicated, but you know, way is very similar, and you know, you need to practice more by using short circuit way, and also there is some Norton node voltage analysis and mesh current method. Either you can use it. There is solutions, and you can take a look at it, and you need to practice.